Thank you so much, Professor Sandhir, for that very fascinating lecture. I must say that I'll see hydrogen sulfide in a completely different light from today. Quite unlike my school chemistry experiences. So we have received a lot of questions from the audience, and I'll take them one by one. So beginning with a very basic question, what is the criteria to be met for a molecule to be considered as a gasotransmitter? Are all endogenous gaseous molecules considered a gasotransmitter, or is there certain criteria that needs to be met?
I don't know whether we see other gases in the system. We have discovered 3 so far. And I would say the criteria to meet this would be you should be able to show biosynthetic mechanisms, pathways for this, and you should be able to show modulation of these in different conditions. For example, I showed you they had used CBS inhibitors to show down regulation of this. So we want to just show that this is not serendipitous discovery that is coming as a byproduct of something. So if it has a role to play, you should be able to demonstrate its effects in the system. So I would say this H2S story has been there for now 30, 40 years. But the interest is now in the last, I would say 15, 20 years that we are emerging to understand its role. And there are patented molecules now available, which people have tried to deliver these in vivo in experimental studies. As far as treatment, I don't know whether therapeutics people have gone as far as this molecule is concerned.
Right. There is a question from the audience where they want to know whether, treating a patient undergoing cardiac arrest with some sort of, H2S, whether treating them internally, would that help the patient?
See, I will not be able to answer this for the reason when we talk of bedside situation, it would be very, very different. When I talk about experimental setup, where I'm using a rodent model, the story is different, everything is controlled. Whereas patient setting, every patient is different. So it will be long way to answer your question because you have to have preclinical studies and look at dose response. These are still, I would say, things in infancy. We only, I would say, emphasize that we've understood its role, but taking them to therapy would be a long journey, I would say. Yes, what you say, I also said pleiotropic targets, multiple targets, and maybe the targets might be a bit different than what I see in other areas.
Thank you, Professor Sandhir. So the next question is about the source of H2S. So what is the source of H2S in the cells, and how does its polarity and ionization in aqueous media affects its role or the rate of its reaction with other biomolecules?
I would say this is a very short-lived molecule. The pH, the stability is very low. And I would say maybe the time would be in seconds or milliseconds. I don't have the numbers with me. And definitely pH and other conditions would influence its ionization. What is the other question? I probably missed that. The first part was something.
And what is the source of H2S?
H2S source, I said, is the sulfur-containing amino acids that we have in the body. Homocysteine is the single most important molecule which is there. And there is an inverse relationship between H2S and homocysteine. More you have homocysteine, lesser you have H2S, interestingly. For the reason there is a feedback control. H2S would also inhibit these enzymes with something like feedback control. So there is an inverse relationship between these. So sulfur-containing amino acids are the major source.
Thank you, Professor Sandhir. Now, because you mentioned that it's a very short-lived molecule, how do we track it in human cells? And when you mentioned that it was discovered for the first time and this is the quantity of H2S in a healthy brain, how was it detected?
Now there are probes available. A lot of interesting fluorescent probes are available. People have spent, I would say, I did not talk about that aspect. For sure, that is important. So they have come up with very, very interesting tools to detect these now. Even protein modifications that I showed you, you have fluorescent probes to detect those also. Whatever I'm saying is all now demonstratable with tools that are currently being employed. So tools for detection of modified proteins. You have tools for detection of H2S. lot of techniques are there. So we use simple techniques which are fluorescent based for detecting in our setup also. We've estimated H2S levels in our setup also. So you can easily measure H2S now.
That's fascinating. And Professor Sandhir, what is the fate of H2S in the human body?
What is the fate? That means elimination.
Yes.
There are excretory pathways, they will be degraded. And since we said HS would be degraded to inactive molecules, modified, and then eliminated through excretion. So it is rapidly cleared from the system, so it doesn't accumulate. And I said already the half-life is short.
Right. And does H2S play any inhibitory role in transcription and translation processes of amyloid beta protein?
Yes, that is. No, I did not encounter any study where they have said they are only saying processing of the amyloid protein, but transcription and translation, I could not find any study. Neither I could find any pathways where they've indicated it to interfere in any other proteins also, translation and transcription. So there will be something, this is something that we can look at, and I probably have not encountered any reference on that. But that's an interesting thought. I will also have a look at it.
Thank you, Professor Sandhir. You mentioned that H2S also has some role to play in cancer etiology. So is there any research going on regarding sensing of H2S as a possible biomarker for diseases like lung or gastrointestinal cancer?
Interesting. I would say no, but that's an area to look at. That's a problem for one of the participants sitting in the audience get to take up research in this area. That will be interesting to look at how can we do a correlation studies with the prognosis of a cancer patient and things like that. That will be interesting.
Sure. Thank you, Professor Sandhir. So what is the current status of H2S based gas therapy in terms of clinical translations? Are there any FDA approved H2S donors right now currently under clinical trial?
I think I said this in few parts. There are n number of molecules available for therapeutics, but I am not sure if any one of these molecules have reached the clinics as yet. But I would say we do expect them to reach clinics sooner, and they might act like vitamins in certain conditions if you can optimize the right amounts of H2S.
Thank you so much, Professor Sandhir. If you have to share one concluding thoughts for the audience from your talk today, please share that.
I would say I was looking at the internet, and in 2015 or so, ACS called it a molecule of the week. And I would say this molecule is potential. And we would see, as in the case of nitric oxide, we have developed a lot of therapeutics. You will see in the next few years, we might see some therapeutic molecules which would be modulating H2S levels available for patient care.
I think now I'll just thank everyone and we can. So thank you everyone for basically attending this session. This has brought us to the end of the session. We hope that you have enjoyed this broadcast, and we invite you to view the edited recordings from the past events in the ACS Science Talks library. At the end of the session, you will receive a brief survey. Kindly share your feedback with us so that we can continue to improve and serve you better. On behalf of all of us, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and stay healthy. Thank you, everyone.